Hello everyone. Today I'll be walking you through some of the key concepts in trigonometry. Let's start with a little bit of history. Trigonometry has been around for thousands of years. The Babylonians in around 1800 BCE were already working with what we now call Pythagorean triplets. This was long before Pythagoras came along. In Egypt, engineers used slope calculations while building the pyramids, what they called the Sekid, which is an early form of trigonometric reasoning. Later on in Greece, Greek mathematicians like Hipparchus and Ptolemy created chord tables. This was done to help with astronomical observations. Then during the Islamic Golden Age, scholars introduced the six main trigonometric functions which are still in use. By the 18th century, trigonometry had become a part of formal academic study, including textbooks which were published in England. Now let's move into something we use all the time, that is angles. We usually think in degrees, but in higher level mathematics, we often use radians to calculate angles. Radians might seem unfamiliar at first, but they're actually more efficient. By definition, 1 radian equals the angle created when the arc length equals the radius. For example, as you can see at the right hand side of the screen, a 180 degree is simply pi radians. Now let's talk about one of the most important ideas in trigonometry, which is a unit circle. It's a circle with a radius of 1. As a point moves around it, its coordinates give you the cosine and sine values, as you can see in the figure down below. The sine function is probably one of the most familiar of all. Its waveform, as you can see in the figure down below, it starts from 0, goes up to 1, down to negative 1, and then repeats itself. This wave pattern is found everywhere around us, in light, in sound, and even in things like heartbeats and ocean tides. Understanding sine function helps us understand how systems behave when they move or repeat themselves over time. Here we've got some common values for angles like 30 degrees, 45 degrees, etc. These values come in a lot of mathematical problems. So being familiar with them really speeds things up when solving mathematical equations. Now let's take a quick look at how these common trigonometric functions behave visually. As you can see in the graphs, sine and cosine both produce smooth wave patterns, and cosine is basically a shifted version of sine. Tangent, on the other hand, increases quickly and has vertical asymptotes. It looks a bit chaotic at first, but it follows its own rules. At the right hand side of the screen, we have shared some of the relations between the common trigonometric functions. Trigonometric identities. Trigonometric identities basically help us rewrite and simplify equations. For example, one of the commonly used trigonometric identity is sin x squared theta plus cos x squared theta equals 1. Once you're comfortable with these identities, solving more complex problems becomes much more manageable. Moving on to one of the most interesting part about trigonometry, its real world use. As you can see, we have portrayed few of the common applications of trigonometry in real world. And to get into a bit of detail, I've outlined two major applications: the study of sound waves and astronomy. In sound engineering, sine waves model pure tones. As you can see in the graph below, when you mix multiple sine waves, you get more complex sounds like chords in music. This is how audio softwares and synthesizers work behind the scenes. Another common application of trigonometry is in astronomy. Trigonometry helps us calculate distance between different celestial bodies. By using just angles and basic measurements from Earth, scientists can determine distances to stars and planets. You'll also see trigonometry in architecture, GPS technology, signal processing, you name it. So, to wrap everything up, trigonometry functions are far more than just tools for solving triangles. They help us describe and understand patterns, especially ones that repeat themselves. Whether we're looking at the waves of the ocean, sound frequencies, or the motion of planets, trigonometry is at the heart of it all. Thank you.